right, hello everyone. My name is Timothy Lee Grant, and welcome to another LeetCoding video. So we are continuing our journey on heaps. I think I'm gonna do an easy problem today because I'm feeling uneasy. I need to give myself a little bit of a break. So essentially what I'm gonna do is I'm just gonna come here and find the next easy that I haven't done. But this one is locked, so not that one. Easy, already done it. Easy, already done. There's not many easy questions here. Oh my goodness. Okay, here we go. Find the subsequence of length k. Okay, so here we go. Let's do it. All right. 2099. Find subsequence of length k with the largest sum. Okay. You are given an integer array nums and an integer k. You want to find a subsequence of nums of length k that has the largest sum. Maybe it's because I'm tired, but I don't quite get it yet, but we're going to reread this. Okay. You are given an integer array nums. Okay, so nums is a list and it contains integers. We're also given a single integer called k. You want to find a subsequence of nums. So I want to find a sublist of this full list called nums that has the sublist has k elements, and I want to maximize the sum. Okay. Return any such subsequence as an integer array of length k. So I need to return back a list containing those elements. So I don't return the actual sum, I return a list of integers. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Okay, so by this definition, does that mean that I can delete things in the middle? So like, for example, if I have 2, 1, 3, 3, and this k value is 3, so I can have 3 elements, can I just drop this 1? And then I can have 2, 3, 3? Because it says by deleting some or no elements. So by deleting some. So I just deleted 1. Is that legal? Can I do that? Without changing the order of the remaining elements. That doesn't change the order of the remaining elements. Look, bam, I deleted it. It's still 2, 3, 3. So by this definition, it does seem like I am allowed to do that. Okay. So in this example, k is 2, and it's just 3, 3. That makes sense. Here's the subarray right there. And it has the largest value, obviously, because 3 is the largest value in that list, and 3, again, is also the largest value in that list. So putting the largest and the largest together is going to give you the highest value. Okay, so this one here. Ooh, we're allowed negative numbers. That's fun. -1, -2, 3, and 4. Now k is 3. All right, so this one should be like 4, 3, and then 1 right here. And I drop this -2. Okay. Okay, yeah. Same thing here. So k is 2, and I just pick the highest elements. So like 3 and 4. Okay. All right. So the way I think I'm gonna do this is I am given a list of numbers. So I'm gonna have whatever, like 4, 6, 7, 3, 99, 12, like this, whatever. I am going to take each of these numbers and I'm going to put it into a heap, but I'm also going to keep track of the index in which they appear here. Yes. Okay, so if I keep track of the index which they appear in the original list, then what I might be able to do is like pop from the heap. And each time I pop, I'm going to get the largest number. And I know that I need to include this number in the sub list, my answer sub list. But I don't quite know where to put it, right? So I need some way to be able to determine how I put it in. So how am I going to do that? The first idea that I had, that I'm just having right now, but I don't think it's correct, is if I put in just like, no, that's not going to work. I was thinking about just like, is it bigger or less than, but then is it bigger or less than what? So I would need to traverse the entire list each time I want to add an element, which is horrible efficiency. Because in order to traverse, so I have my answer here, and I'm gonna, okay, first put 99 here, and now I want to put 12. So do I put 12 here, or do I put 12 here? Well, I need to put it here. And how do I know that? Well, okay, so this index value, so here's the actual value, but then here's the index value, which it would be 0, 1, 2, 3, 4, 4, is smaller than this one's index value, which is going to be 5. Okay. I mean, I could slightly make it more time efficient if I used something like a binary insert. I don't know what the exact terminology would be, but essentially where I did like, I have my answers list and then I check the middle element, because the middle element, these indices are going to be in ascending order. So I'm able to check the middle of my array and check, is the value I'm trying to insert, is its index larger or smaller than the middle element? If it's larger, I then go to the middle, like I say, okay, great. So I cut the subarray in half and then go to the upper bound of that list. And then I say, okay, now take the middle of this sublist. Now is it bigger or smaller? Oh, it's smaller. So great, then go to the smaller element. And so that's a log of n time, which could be acceptable. I don't know if, is there a way, I want to get it like O of 1 though. I really wish I could get it. Oh, I feel like I should be able to do. Is there something that I could do with like dictionaries to get it to O of 1? I really want it to be O of 1, please. Hi. Okay, whatever. Let's work with the idea that we have here, and then if this is good training, because I also don't exactly, saying how to do a binary insert is one thing, but actually doing it is a completely other thing. So this is actually really good practice for me to actually go through and do a binary insert problem, because I haven't done one before. I know the concept, but I haven't implemented it, so this will be really good. Okay, so I'll move forward with the way I'm thinking, and then see if there's a way to increase the efficiency. So let's just start. So I have this list. Okay, so I have nums, and I want to heapify this list nums. Okay, so I also don't necessarily want to change the nums here, so I might do something like my heap equals nums dot copy, like this. Okay, now what can I do? I want to heapify this list, so I do heap q dot heapify and then my heap. So this function operates on this heapify list. So this is a list, and this method, this function right here, changes my list, just the order. It changes the order. So it's still a list. It still operates kind of like a list, but the order is such that it conforms to the heap protocol, essentially, and I'm able to perform heap operations. So great, now my heap is an actual heap. But it's still a list. It's still just a list, okay? Actually, did I need... No, I don't think I needed to do that. So, because I need both, when you heapify it, it changes the index. So I need to do something like this, where I do a for loop. So for so for index element in enumerate nums. So I'm going to get the index and the actual value in the nums list. So I'm going to store both of this information into the heap. So I'm going to do my heap dot heap q dot heap push. There we go. And now we want to push onto my heap. That's the list. And we need to make a list. So my heap right now is an empty list. And then we're going to continue to add elements to the list. How many elements are we going to add? We are going to add each element of nums. So we're going to add 2 into our heap. We're going to add 1 into our heap. We're going to add 3 onto our heap. We're going to add 3 onto our heap. And then what we're going to do is we're going to constantly pop from that heap and get the largest number. Okay, so now, what do we actually want to put into the heap? So let's make it a list. So we're going to put in our big list, we're going to put small lists. And in our small list, we're going to have 2 elements. The first one is going to be the actual value. That's element. What's the second one? The second one is the index, because we want to keep track of that information. And now why do we put the element as first? Well, because when we do the heap push, this function will draw the largest, actually the smallest, sorry. So when we do a heap pop, so when we get an element back, it is judging that element by what is the smallest element in my list. So I'm going to get back the smallest element. And so I want to, and it is judged by the first element. If you do a, so normally in a heap, if you only have, instead of a list, so it's a list of lists, this time let's think about like a list and it's just integers. You pop from the heap and you get the lowest integer, the smallest integer. In my case, what I'm doing is I'm having a list, which is the heap, but inside that list is smaller lists. And now when I pop, how is it judging? It's judging what is the smallest element in the first element of your sublist. So it's judging based off of this element. Now, I just said the smallest, but we actually want the biggest, right? So when we pop, when we do heap q dot heap pop, we want to get the biggest element, but the heap pop will give the smallest element. Well, how do you fix that? You just negate it, and now the biggest element is actually the smallest element, but we kind of need to keep track in our mind that we negated things. So let's just negate this element. So we're actually going to be putting -2 in our heap, then -1, then -3, -3. Okay, so now, cool. So that right there, actually, I just realized because this right here is O of n, then log of n time complexity shouldn't matter. Although I do have to do it in time, so it would be log of, or in log n, which is worse than O of n, right? But, okay. Anyways, focus. What am I doing now? So I have my heap and the element. Okay, so now I need to do, actually I would do it k times. K times. We have to insert into our answers list k times. So, what do I want to do? What do I want to do? For element in range k. That may be what I want to do. I don't know. For I in range k, I don't know. Anyways, so I want to go through my list k times. And each time I want to pop, actually, I don't even think I need this I. I'm just going to go like that. So each time I want to pop from, so current element equals heap q dot heap pop my heap. So I'm popping from my heap, and I get back what? A list. And what does that list contain? It contains the negative element and the index at which it is found. Okay. So now I can call, like, insert sorted, and we need to write that function ourselves, but on current element, and also our answer list, or our, and this wouldn't be our actual answer list though, because the answer list needs all of just the elements, not the elements and the index. So, I don't know, temp list, something like this. So I'm gonna do like temp list is an empty list, and then answer is also going to be an empty list. So then we're going to create those. Okay, so I need to create this insert sorted. So def insert sorted. Okay, and then I am doing something, which is I have my temp list, okay, and then current element, okay, and then I am going to sort this. Yes. So, this is that binary insert. That's what I'm going to call this. Binary insert. Binary. If you can hear the fireworks, it's December 31st, so it is New Year's. Yes, leak coding on New Year's. Yes. Every day doing LeetCode. No such thing as a holiday day off. Every day LeetCoding. Okay. Binary insert. Okay. So now, what does this function do? I need to... So... Start equals 0. End equals length of temp list. That's what I'm trying to insert into. So while start is less than, should I do equal to? Yeah, I think I should do equal to end. So then we're going to keep going until we okay, so I need to find the midpoint, right? So midpoint equals start plus end divided by 2. Divided by 2. Okay. So now, if temp list indexed at midpoint is greater than current element, then what do we do? If it's greater, then start equals midpoint plus 1. Okay. And then if it's the other way around, right? No, LF here. Then I want to change end equals midpoint minus 1. Okay. I remember there was some problem. I think I'm doing this wrong. Yeah, I think I remember there was I remember why I hate binary insert, because I remember doing this wrong and it was like one thing off, and I couldn't figure out why. And I should have studied it. I didn't study. I messed up because I did this one time. I couldn't figure out how to do it. And then I should have taken the time after I did it and just memorized how to do this binary insert, because now it's coming up again. And guess what? It's still a problem. It didn't go away. Ignoring your problems doesn't make them go away. um okay, so I'm yeah, that I don't know. I know that there's a problem. I'm gonna ask GPT how to do it. I'm gonna put that into here, and then later I am going to memorize how to do a binary insert. Okay, so I have a list in ascending order. I want to insert an element into this list using Python. Show me the implementation of a binary insert. Okay. I wish I had some coffee. There's no coffee. I keep looking in my. We'll use bisect module. Import bisect. That's actually no. I wanted to. No, don't show me any modules. Show me the actual thing. Like, how do you actually do it? So binary insert is here. Bisect left. Element. Sorted list. Partition element. Don't use any modules. Show me the actual implementation so I can learn. Because I need to find something that I can memorize. Not really memorize, but, you know, like, look over and over and over and over. Yeah, this is looking more like it. Yeah, this is it. Here we go. So, okay. The length of the sorted list. Yes. Correct. Good. Now, what do I need to do? Mid is left plus right divided by, but it's integer division, okay? Yeah, see here, this one is left plus 1, and then this one is just equals mid. Okay, so let's I'm just gonna like 1 for 1 do that, because I don't want to be making any mistakes right now. Also getting a little bit tired right now, to be honest. So left equals 0. So that's start is left. It's at 0. Right is the ending. So left is start, right is end. Okay. And now that's length of temp list. Okay. So while, and it's not equal to. So I said while they're greater than or equal to, but apparently it's not equal to. So left is smaller than right, which that kind of makes sense because left is 0, right is at the end of the list. Okay, so midpoint equals, and then left plus right, and then integer division 2. Okay, so if temp list indexed at midpoint is less than current element, and now current element is here, but I actually want the index value, which occurs at the first, right? Because we're storing this index at the first index of this list. So I want that. And then temp list is going to have, temp list is going to be midpoint, but indexed at the second index, right? Or the first index. So 0 and then first index. Okay, so then if this is the case, then we do left equals mid plus 1, and then else, they don't even do a check, so it's just else, right equals mid. Okay? So now you exit the while loop and do an insert. Okay. So I am going to insert into my sorted list. So temp list dot insert left. Wait, left is the index. Okay, and then element is the element I want to do. So current element. Okay. Now return temp list, but I don't think I need to actually, do I need to return it? If this operation, because this is an array that's passed in, do I need to actually, it doesn't the change stick with it? That's something to figure out later. I'll figure out that later. So maybe I do something like temp list equals, and then I have here, I don't know if that's necessary. I might be able to just delete that part and keep that. But anyway, so I do that k times, and then I need to create my answers list. So I have a list which is essentially the answers. It is all of the values of my sublist, and there's k of them, and it has the value and the index that it is stored at. So now I need to go over this list and just take the value of each one and put it in my answers list in that same order. So for element in, what did I call it? Temp list. Okay. Answer dot append element, and it's the first index. Then what are we going to do? We are going to return answer. Okay, let's what do you want to do? Do you think it's going to work? Do you think? What do you think? What do you think? Before I press submit, do you think it's going to work, or do you think I made a mistake? I don't know. Let's try it. Wrong it, darn. Oh, it's because they're negative. Yeah, duh. We need to append the inverse because we negated everything, remember? We negated everything. So we need to append the negative of it. So, okay. That one didn't count. Okay, awesome. We got it. Cool. Now, I guess, yo, nice. I'm curious, like, is there a, because my answer was kind of down here, I'm kind of curious, like, was there a more efficient solution? So I'm gonna, again, take this to GPT and see if it gives me a suggestion. And I need to memorize this right here. Like, this is something that I have to do. Like, that's not really an option. I can't be lazy. I can't. It's gonna keep coming up. And I have to do it. Okay, so why does it say attempted? I solved it. I solved it. That's right. There you go. Okay. here is my answer to, and then here, do you see any optimizations in algorithms that I could have used to make it better? Let's see what it has to say. No thank you. Maybe later. Okay, so let's see what it says. Your approach is a solid start, but there are some optimizations we can make to improve both performance and readability. So right now, I'm not too worried about the readability. I want to figure out like my performance, because right now I believe it to be O of K log of N, I believe, where N is nums, length of nums. Okay, so instead of using a heap and binary insertion, we can simplify the problem by finding the k largest elements along the indices and then sorting those indices to return a subsequence of the original order. I really wish I had some water. My throat is anyways, so find the k largest elements. Use a max heap to get the k largest elements. Okay, cool. And their indices. Cool. Sort the indices. Sort the indices of the selected elements to maintain the order and appearance. Okay, construct the results. So let's, okay, this looks a lot more clean. So let's look at it and figure out what's happening with it. So max subsequence. Right, so max heap, and they're doing the same thing. I just put this in like a full for loop, but they're just creating a list of the negative number and the index, and they have the index a second, which is exactly what I was talking about with why we had to have index second and the actual element first. Then they heapified it just like I did. Okay, and then extract the k largest elements. So now you're creating a list, and each list you're just popping the largest element and then inserting it. Or no, just creating that element. So you're going to take the largest element. Oh, I think they're just going to sort it by the... Oh, okay. So essentially, it's the exact same method that I was using. So instead of what I did was I popped an element, and then I did a binary insert. Each time I popped an element, what they did is they popped an element, they put it in a list, so they got the biggest elements in the list, and then they performed a sort on that list that they just created called largest elements. And so they then they extract the indices and sort them. So indices equals sorted, so that you can use that sorted. And then based off of the index. Okay, and then you don't do anything with the number. Construct the results subsequence. So result equals nums of I for I in index. So num. Oh, so then we just get the index, which corresponds to which one we plugged in, right? So let's say index 3 in our original list, index 0, 1, 2, we want to take this element. So we pop it and we keep the index. So it's we pop this one and it's 0, 1, 2. So we have 3 and 2, or even just 2, right? So we have that, and we only need to keep track of the index. So it's at index 2. And that information we then use to say, okay, what appeared in our original list at index 2? It was 3. So just insert 3 there. So this is our original list, and we take the second index, index 2, I should say, and what value is that? It evaluates to 3, so we put 3 there. And because indices is sorted based off of the index, then it's sorted. Okay, that's pretty smart. So moving forward, what I need to do is obviously I need to memorize, where'd it go? This guy, binary insert. So this is something that I understand is going to keep like coming up over and over and over. It's not going to go away. I know I can't just ignore it. I need to hunker down and actually do it. So that this is kind of like my homework. I'm going to be doing that off screen. I'm going to be looking it over, trying to understand it, learn it. And then, yeah, next time I see this type of problem, I'm not going to stumble on that. So anyways, thank you guys so much for watching this LeetCoding video of the day. LeetCode problem of the day, right? Video. So thank you for watching it. If you would like, subscribe. I almost have 100 subscribers, so I'm really happy about that. Thank you to everyone who did subscribe, and I will see you guys tomorrow with another LeetCoding video. So thank you for watching. My name is Timothy Lee Grant, and I will, yeah, see you tomorrow.